The first law of thermodynamics: when a system undergoes a thermodynamic cycle, then the net heat supplied to the system from the surrounding is equal to net work done by the system on its surrounding. The first law of thermodynamics may also state the following: heat and work are mutually convertible, but since energy can neither be created or destroyed, the total energy association with an energy conservation remain constant. The thermal energy reservoir, the source is a reservoir which supplies the thermal energy without undergoing temperature changes. Sink, it is a reservoir which absorbs the thermal energy without undergoing any temperature changes. The second law of thermodynamics: Kelvin blank statement, Clausius statement. The Kelvin blank statement: it is impossible to construct an engine which, while operating in a cycle, produce number other either effect expect to extract the heat from a single reservoir and do equivalent amount of work. Clausius statement: it is impossible for a self-acting machines working in a cyclic process unaided by an external agency to convey the heat from a body at a lower temperatures to a body at high temperatures. Reversible process. A reversible process should fulfill the following conditions: the process should not involve friction of any kinds. Heat transfer should not take place with a finite temperatures difference. The energy transfer as a heat and work during the forward process should be identically equal to energy transfer as heat and work during the reversal of this process. There should be no free or unrestricted expansion. There should be no mixing of the fluids. The process must proceed in a series of equilibrium states. Heat engines. A heat engine is a device which converts the part of heat into work reject remaining to sink or surrounding. The source supply heats Q1, heat energy W, Q2 heat rejected, sink. Q1 equal to W plus Q2, work done equal to Q1 minus Q2, efficiency equal to output by input, efficiency Q1 minus Q2 divided by Q1. The equation 1 valid from both reversible and irreversible process cycle. The Clausius statement: it is impossible to transfer the heat from a lower temperature to high temperature without any external input. The refrigerator is a device which made in lower temperature than the surrounding. As lower temperatures are to be made in continuously, refrigerator must operate on cycle. COP, desired effect divided by energy input. Q2 divided by W, Q2 divided by Q1 minus Q2. Surrounding T1 high temperature, T2 lower temperatures. Heat pump. Our heat pump is a device which maintaining high temperatures compared to surrounding. Q1 equal to W, Q1 divided by Q1 minus Q2. Relationship between the COP and heat temperature. COF HF. COP equal to 1 plus COP sufficient R. The perpetual motions are machines of the second kind. The impossible develop the device operating a cycle which produces a work while exchanging heat with a single reservoir. In this devices known as ppm2 and efficiency ppm2 is 100%, and other efficiency 100% efficiency is impossible from the second law of thermodynamics. Without violating the first law, a machine can be imagined which would continuously absorb the heat from a single thermal reservoir and would convert this heat completely into work. Efficiency of such a machine would be 100%. This machine is called perpetual motion machines of the second kind, ppm2. The thermal reservoir perpetual motions machines. This is a Carnot cycle diagrams, Carnot cycle engine, Carnot heat pump. The 1 and 2 isothermal expansions, the temperature start from T1 to T2. The adiabatic expansion 2 and 3, isothermal compression 3 and 4, adiabatic compressions 4 and 1. Isothermal expansion, adiabatic compressions. The Carnot heat pump cycles. The volume. The Carnot cycle consists of isothermal process and 2 adiabatic process. Isothermal process is a slow process and either Static process is a fast process, and hence this combination is not possible in the cycle. Therefore, Carnot cycle is a theoretical cycle and used for the comparing other actual cycle. Clausius inequality, it states that of all engines operating between the given constant temperature source and a given constant temperature sink, none has higher efficiency than the reversible engine source T1, sink T2, Q1, Q2, Q1B, Q2, Q2B for 10. HEA and HEB are the two engines operating between the given sources and temperatures and the given sink temperatures T2.